given by E is equal to mc square, isn't it? Yes. Here what is E? E is the energy, m is the mass, and c is the velocity of light. Okay, well? Then according to Max Planck, he is another scientist. According to Max Planck, the energy will be given by E is equal to h nu. Okay, this we can take as equation number 1 and here equation number 2. And in both these equations, here also energy term and here also energy term. So we can equate them. By equating, we can write mc square, that is equal to h nu. Okay, here E is the energy, h is the Planck's constant, and nu is the frequency of light. Okay, and the value of nu will be equal to c by lambda. Okay, so mc square is equal to hc divided by lambda. Okay, we need the value of lambda, so we can bring this lambda this side and mc square down. Okay, so lambda is equal to hc divided by mc square. Okay, okay, so here also c, so we can cancel those terms and we can write lambda is equal to h by mc. It is the wavelength for a light particle. Okay, lambda is equal to h by mc, and almost we have derived the de Broglie equation. This is de Broglie relation. Lambda is equal to h by mc for light particles, because c is the velocity of light. When we study about any material particle, this c can be replaced by v, velocity of any material particle. So we can write lambda is equal to h by mv. And students, we know that the value of momentum means mass into velocity is equal to momentum. So lambda is equal to h divided by p, where p is the momentum of the particle. This is de Broglie relation. According to Einstein, the energy of light is given by E is equal to mc square. According to Max Planck, the energy is given by E is equal to h nu. Then mc square is equal to h nu. Nu value is equal to c by lambda. So mc square is equal to hc by lambda. Then we can bring this mc square down. So lambda is equal to h by mc. This for light particles. Then for material particles, this c can be replaced by v. So lambda is equal to h by mv, and m into v is equal to momentum, that is p. So lambda is equal to h by p. This is called as the de Broglie relationship. Okay, and this de Broglie relation has a small disadvantage in arena. It is applicable only for microscopic particles. It's not applicable for macroscopic particles. Peரிய particles, this relation will not be helpful in finding out the wavelength. Only for microscopic particles like electrons, protons, we can use this relation for finding out their wavelengths. Okay, so that we can see through an example. There are two objects we are going to take. Those objects are an ion ball and an electron. Ion ball is macroscopic, whereas electron is microscopic. Electron we cannot see with our direct eyes, no? So that is microscopic. Okay, okay. So two data are given. First one, ion ball. An ion ball with mass. The mass of ion ball is given 6.626 kilogram. 6.626 kilogram, and it is moving with the velocity of 10 meter per second. Okay, so from this data we can find out the wavelength. What's the formula for wavelength according to de Broglie? Lambda is equal to h by mv. Then h is the Planck's constant. Its value will be 6.626 into 10 to the power minus 34 kilogram meter square per second. This is the value of Planck's constant. 6.626 into 10 to the power minus 34 kilogram meter square per second divided by m. The mass of ion ball is given that 6.626 kilogram into the velocity is given 10 meter per second. Then cancel the units. Kilogram cancel, meter cancel, per second cancel. Then Here what do we have? 6.626. Here also 6.626. Those terms also we can cancel. And finally, the value of lambda will be equal to 1 into 10 to the power minus 35. This is the value of lambda for ion ball. Okay, 1 into 10 to the power minus 35 meter. Just imagine students, 10 to the power minus 35 means the value will be very small. 0.0000, 34 zeros we have to write and then 1. So this value is very small. We cannot study this. Then second one, we can take an electron. For electron, the mass will be 9.11 into 10 to the power minus 31 kilogram. This is the mass of electron and it is moving with the velocity of 72.73 meter per second. For this electron also we are going to find out the wavelength. Then by applying the formula, lambda is equal to h by mp. H is the Planck's constant, no? 6.626 into 10 to the power minus 34 kilogram meter square per second. Then divided by mass of electron is 9.11 into 10 to the power minus 31 kilogram into velocity is 72.73 meter per second. Then by cancelling all these terms, the value will be equal to 1 into 10 to the power minus 5 meter. It is somewhat larger than this one. Here 10 to the power minus 35, but here 10 to the power minus 5 only. This value we can study. So from this, what we are going to conclude is this de Broglie equation is helpful for finding out the wavelength of macroscopic particles like electrons, and it will not be applicable for macroscopic particles like ion ball. The de Broglie relation is applicable only for microscopic. It's not applicable for macroscopic. For macroscopic particles, the wavelength will be very small, so it can't be studied. So this is the application of de Broglie equation. What is de Broglie equation? Lambda is equal to h by mv. Okay, the remaining things we can see in the next video. Thank you.